Yeah, hello, and thank you for joining. I'm Seung-Jun from ETRI. ETRI is the National Research Institute in Korea. So today I'm excited to introduce our work on OmniXtend, an open coherent memory fabric designed for RISC-V systems. Our goal is to enable memory-centric computing even for tasks like LLM, inference on resource constraint, RISC-V systems. Yeah, AI is moving to the edge, and that is including large language models. Users increasingly want to run AI workload locally for latency or privacy or offline access. But the RISC-V systems is not easy. First, we lack necessary compute and I/O performance, but more importantly, memory is the bottleneck. AI models like Llama or GPT grows rapidly in size. Even a relatively small version, 3 billion parameters, requires more than gigabytes of memory just to load. On memory restraints in RISC-V systems, AI inference either fail or becoming impractically very slow. So here is a clear example showing how system memory directly impacts LLM inference performance. We are looking at the relative compact model, Llama 3.2 and 1 billion parameters, which requires around 1.2 gigabytes of memory. On the left side, the system has more than 1.2 gigabytes of memory. Yeah, in the case, the inference processes smoothly at 2.74 tokens per second, fast and stable. But on the right side, the system memory is below 1.2 gigabytes. Now the model struggled, and the performance drops below 1 tokens per second, and the system may even run out of memory or start swapping. So this result shows that the inference throughput is strongly influenced by available memory. So what is the solution? The key is to ensure the system have enough memory. So can we add just more memory to the board? In many RISC-V systems, there is not practically. There is a physical limit, power and heat constraint, and often no high-speed expansion interfaces. RISC-V platforms are designed to be lightweight, and that includes their memory architectures. Instead of scaling memory locally, we need a smarter approach that fits the RISC-V philosophy. So that's where OmniXtend comes in. It allows us to access memory over Ethernet, providing scalability without changing the core system design. OmniXtend is an open coherent memory fabric designed for RISC-V systems. It lets a processor access external memory over Ethernet while maintaining cache coherence. The core idea is simple. Instead of adding DRAM to each board, we connect nodes to the shared memory pool, like a fabric. Yep. And OmniXtend isn't limited to the RISC-V cores because as it's built on the standard Ethernet protocols, it can also be used to connect to GPUs, NPUs, or other accelerators, allowing each processor or accelerators to extend its memory independently. This is the core strength of OmniXtend, our open memory fabric designed specifically for the RISC-V ecosystem. First, it is built on the open hardware architecture. By using RISC-V, we support customizations, openness, and innovation, enabling researchers and developers to adapt their system freely. The second one is it enables the agile hardware development. Using Chimney framework, we can rapidly prototype new idea, test them iteratively, and move faster from concept to implementation. And third is the most importantly, OmniXtend uses Ethernet as its memory fabric backbone. Ethernet is universal, fast, and already well supported. This makes OmniXtend a scalable and cost-effective solution for connecting processors to memory, crossing the chips, boards, and even racks. The OmniXtend version 1.0.3 is a stable and high-performance protocol that delivers tight-link over Ethernet. Its key feature is include coherent memory access, reliable end-to-end flow control, and automatic retransmission, and support for a wide range of use cases. These capabilities make it ideal for building scalable and efficient memory systems. I'd like to revisit the experiment we saw earlier. And this time, instead of relying on the local memory, we add about 5 megabytes of remote memory through our memory fabric. With the addition, the system has just enough memory to run AI workload. The result, we achieved 2.69 tokens per second, which is almost identical to the test case with the full local memory. This confirms that even a small amount of remote memory can restore performance and make LLM inference feasible on the resource-limited systems. To wrap up, OmniXtend is an open-source memory fabric specifically designed to overcome memory limitations in RISC-V systems. And the protocol is publicly available and easy to adapt, so allowing developers to integrate it into their own hardware platforms. But more than just the technology, it is growing ecosystems. We invite you to join us, contribute idea, building tools, and help shape the future of open memory fabric. Yeah, thank you for your time and attention. Please feel free to reach out anytime you want. Yeah, we have a booth on the first floor, and please come by and see the other live demos. Thank you.
Yeah, thank you very much. And we've got time for questions. There's one from Simon again.
Thank you. Very interesting. You say it's coherent. Do you run the coherency protocol over Ethernet?
Yeah, that's right.
And are there latency problems with that?
Yeah, actually the latency is not good than the local memory because it's actually far memories. However, the latency is a little bit bad. However, the bandwidth is very nice. So in case of AI workload, the workload requires a very large bandwidth. So the latency is hiding, and the performance is almost same.
Okay. Any more questions? Yes, one over here. Take the speaker.
Hi. Thank you very much for the talk. That was really interesting. Is there any... How do you deal with access control? I guess maybe you don't have to consider this in sort of an AI workload, but if I have a memory pool and I have two people accessing the memory pool, can one be sure that the other person... Is there any way to guarantee for one person that the other person won't access their part of the memory pool? And if so, how do you implement that?
Yeah, this time we just separate the memory region to each host, but it's another story to memory share the same memories. We currently not implemented how to share the same memory. We just to separate the memory region to each host node.
Thank you. Okay, thank you very much for that talk. Very good. And thank you to all our speakers. And thank you to everyone to keep you on time because we finished bang on time. So thank you very much indeed.